Hello. Oh. Hello. Hello, Strange Loop. Thank you for coming to Strange Loop. Thank you for coming to this talk specifically. We know you have a choice when you fly Strange Loop, and we appreciate you being here. Let's do the talk. So I'll start with saying a little bit about my background. I come from comedy writing. I spent a few years writing and editing for ClickHole and the Onion. And since then, I have moved toward creative coding. And part of this talk is a story of how that happened. Shout out to the RC, the Recurse Center, RC, and to Botnik, which you'll hear about later. So in this talk, I'm going to start with a kind of personal history of coming to coding through predictive text, and then talk about small language models on small source texts and some of the reasons we might be interested in those. And then we'll talk about how decisions made when designing models can affect the scope of the creative output. And then we'll close with some karaoke that will hopefully bring everything together nicely. And one theme I think we will return to throughout this talk is the question of what do small language models do well, especially in a world of ever larger language models. So we'll start with the predictive text. And when I think of predictive text, the first thing I think of is this screen on every phone for more than a decade now, it feels like, and certainly on every phone that I knew of in 2015, that has these three options at the bottom suggesting words you might want to type next. And it was in 2015 that I started experimenting with this game where you keep on just taking one of these options and blindly accepting the suggestions from the ether from the most boring person you could possibly imagine. We can go, I am a very nice and warm and sunny day of school. And I remember trying this and immediately only wanting to write like this. And asking the question of, how far can this take me? Could this lead to, I don't think I was asking the question of this, could this lead to a world-killing artificial intelligence back then, but could this lead to a lot of fun was a question on my mind. And the first song I'm going to play for you today is a song written using these rules. You're only allowed to take suggestions from the predictive text on a 2015 Android phone. And you can take as many shots at writing the sentences as you want, but it has to be a direct line of words from the phone. So this is a song called I Have a Great Time With You. I like to think it's a pop song.
I have been working in an email with powerful spam. Please forward this email and destroy all the best of my friends. And your mom and dad's birthday party for her birthday. And she said it was great seeing the pictures of my resume. I have a great time with you. I have a great time in my head. I have a great time in my head and neck and shoulder and the rest. I am not sure how much you want me and my dad. I am not sure how long it took me to get to see the large annoying ads. I have been working in an effort to streamline my name. You are doing great and I am going on the same. I have a great time with you. I have a great time in my head. I have a great time in my head and neck is stiff and sore and tired of spam. Thank you for your time in the future and the rest of the day and night, and then the other day and night, and then the following new year, and then the rest of the day and night. I have a great time with you. I have a great time in my head. I have a great time in my head, and neck is stiff and sore and stiff and sore and stiff and sore and stiff competition to win this thing called the police, and fire and ice cream, cheese frosting, and the rest.
Thank you. So that's what writing with predictive text is like. As I said, it feels like merging minds with the most boring person in the world. And this led me down the rabbit hole that led to here. And it started with understanding that each of the suggestion pages you see was strictly determined by the last two words that you see in your input pane. So if you have the same two words, I noticed you would always get the same two suggestions. And if this holds, then we can model this exploration of the predictive text space as kind of exploring a maze, where every branch we can explore one of three different paths. And if I choose is stiff as the next two-word node that I go to, it gives me three more two-word nodes. And then I choose stiff and as the next word node that I go to. And we can keep going with this, and eventually it connects back to itself, and we can see how we got into that rut there in the middle of the song. And then we can also see how we can break out of it. Stiff competition to win this thing called the police, and fire, and ice cream cheese frosting. So this is very similar in structure to a model of sequences called a Markov chain, or a Markov model. But let's ask, is predictive text as played on the phone actually a Markov chain? The formal definition of a Markov chain says in order for it to be Markovian, it has to have a set of discrete states. Here the states are A and E. And we have to have a set of discrete transition paths between those states that are fixed and known. And we have to have the property that the transitions between these states depend only on the current state. So with phone predictive text, it's almost true. But while we have discrete states and fixed transition paths, the fact that the transitions depend on my choices about which one to go to next means it doesn't have this memorylessness that characterizes a Markov chain. I am the problem that causes it not to be quite as elegantly modeled. So this experiment led me to want to merge minds with someone else other than the most boring texter that could be synthesized from whatever data set the Android phone was using in 2015. And so the next section is dedicated to small models and small text data sets. We could first ask, okay, what's the simplest way to build one of these Markov models? And this introduces us to the idea of ngrams, where an ngram is a sequence of n letters or n words, n tokens in general, from a text. And if you had a source text that had this phrase, I have been, then you might take this stretch of the text and say, this is a three-word long ngram that begins with the context of I have, and one of the possible continuations from that context is the word been. We can write this up in, well, I think this is maybe a point about small language models I want to make, is that because they are small, they are great tools for introducing yourself to a new language. And this was not the first draft of an n-gram model, but it is the shortest draft of an n-gram model that I've written in Python. And it really only takes maybe a surprisingly, maybe not surprisingly, short number of lines to get to a minimal n-gram model of language. All we need to do is split the text on spaces, get n-grams of different lengths. So 1 grams, 2 grams, and 3 grams. Unigrams, bigrams, and trigrams are the counts of how many times words occur in the text overall. That's the simplest model you could have, and running just that one would be equivalent to just randomly choosing words from a bag. Bigrams are modeling it as we only have a context of size 1, and there's always a continuation of size 1, and trigrams are what we saw in the last slide. So combining these, we can get to a minimal n-gram model where you always are taking the last 1 or 2 words of the text and asking, in the text we have seen so far, what words followed those contexts? And I'm going to just jump out of this presentation to show a working demo of this where we have a Jupyter notebook and we can paste in a source text, which I will paste in a collection of abstracts from all Strange Loop talks ever given. We can put that in the cell as the source text. We can run all. And then if we scroll down a little way, we should get to a little loop where we are always getting a list of 9 common words. And by choosing one of these words, let's choose the. We then get 9 more words. So the language is not necessary. That's a pretty concise abstract that kind of absolves itself of needing to write more. We can also expand this to a little UI demo that we can more nimbly navigate and that doesn't require constantly shifting our attention and handling Colab. This workshop will offer some practical problems based on several important factors. So maybe you're getting the picture. This is a minimal n-gram language model. Let's resume. Will this take us back to the same place? Great. Another component of small models and small data is where do you go to get the data? One option is to find it. Another option is to ask for it. So this is an email I sent to Alex 3 weeks ago. Thank you, Alex, for responding to my I guess, strategically idea request. Seems like a way of easing someone into the idea of giving you source text. But my favorite way to get source text has been using scrapers, web scrapers, which I love partly because they are so fragile and so dependent on the structures of the websites that they are scraping. So I found that over the years, as I've wanted to get reviews from Yelp or Craigslist ads or reviews from Amazon, sometimes the websites change and you can no longer assume that the search page for descending ratings for a certain business is going to be formatted this way. And so you have this scraper that represents a temporary kind of tenuous connection to the data you're after. But they work, and they get the job done. So one example that I'm going to read briefly from, pulled with this Yelp scraper, is a negative review of the Statue of Liberty written by collecting the surprisingly hundreds of negative reviews of the Statue of Liberty available on Yelp. Here's how it goes. I have experienced the Statue of Liberty for the only time. The boat ride is nice, but it took over 5 minutes to even reach the statue. I had a few options. I can go into the pedestal and just admire the tickets I had prepaid for. I can read up on Liberty and Ellis Island. I can sit inside the boat and just smile. I have been too many things in the dead heat of time. I guess I can get good in the freezing cold of the raindrops. The statue itself was a little confused and kind of just stood there. We waited maybe 10 minutes before getting hit with a major bummer. The Statue of Liberty was a ripoff of the Statue of Weather. That's my reading, thank you. Something I want to point out about the process here is by wandering randomly through these source texts, you sometimes get to learn surprising things about what seem to be consistent patterns in the texts. And one of my favorite ones here is this line in the second to last paragraph. Oh, no, the last paragraph. The statue itself. And this formulation of the something itself turns up in a bunch of different Yelp review contexts, where we have, what you get to infer from that is like Yelp reviews are composed of a preamble where we're talking about all the stuff around the event we care about. And then we switch and we say, but here's the real deal about the statue itself, or the museum itself, or what have you. And this is one thing I love about knowing that this text came from a specific place, is knowing that the patterns I see are not that far removed from the patterns that are actually occurring in the text. And I feel a closeness to the people who wrote that text. And I feel like I get to celebrate them for realizing that there's a distinction between all the stuff around a thing and the thing itself. Another thing I like about small language models that they do really well is they are quick to design and quick to titrate combinations of different source texts. So that's something that I'm going to showcase in a moment here with another song, this one combining two scraped or found source texts, Morrissey lyrics on one side, and Amazon customer reviews of the P90X workout system, a series of DVDs to make you beautiful. So this song is called Bored with This Desire to Get Ripped.
The same thing every day is like a workout for my mind. So I'm a marathon runner in my sorry way. Will I be a wonderful shape after completing P90X? I was wasting my money and my overall health on a government scheme designed to push myself to die. I gained an ancient ocean and I cried because I could. Just to see results, I really started to cry. And I think it's fair to say I've gotten bored with this desire to get ripped. When Jesus started using the DVD, I don't care, I just needed to get back to my room. I'm so sickened, oh my God, it really works. I was skeptical during my CrossFit craze. I was 15 times the one I was in 3rd grade. The workouts themselves are insane, but not impossible. Why don't you ask me, what else can I find? And I think it's fair to say I've gotten bored with this desire to get ripped. And I wish I could have read it somewhere, written in a gym. I've gotten bored with this desire to get ripped.
Thank you. So we're now adding things to the world and not just mimicking them. We have a combination of Morrissey and these unsuspecting Amazon customers who never knew they would be co-opted into something like this. I want to take the next section to talk about the effects of your choice of tokenization on the creative space that you are exploring with generative models. So a couple years after the first predictive text experiments, I started a collective/company called Botnik, which experimented with predictive text and other generative methods. And we tended to take an approach where we start with a source text, do some modeling on it, have an editorial process where we filter it through ourselves, and then produce the output. Oh, there you go. So corpus, model, editorial process where the people are kind of suspiciously neural net node-like, and then production, actually making it and showing it to people. And I want to zoom in on the model part of a Botnik project and talk about two Botnik projects. One is this fake chapter of Harry Potter called Harry Potter and the Portrait of What Looked Like a Large Pile of Ash. And the choice of tokenization here is word level. So we are using full words from the source text. It's very similar to the stuff we've just been looking at for the last 10 minutes. And one result of this is that the character names stay intact. So we are going to be using full character names from the source. And we sort of have that guarantee that in this world that people know the names of a lot of the characters, we will be mentioning them correctly, I guess. Contrast this with another Botnik project, a Coachella poster, where the goal is to generate band names based on a source text of thousands of band names. I think we chose the ones that Pitchfork had reviewed. And in this case, it was very important that we used a neural net to just spit out lists of thousands of band names, but you could use a neural net with different sequences than characters. But in the case of band names, it's very important that you do go down to the character level, because part of what makes a band name, or what can make it distinctively band namey, is that it's not a word and wasn't in the source text, and it's like a made-up thing that no one's ever seen before. So with the word level generative process, you could never have a band like Giraffics or Boy/Boys making experimental use of punctuation, or Benmork's Stramplozon, or Plague Brag, or Food Thoid. These would never come up if you chose to tokenize on the word level. So in this case, it was very important that we did go sub-word level. Okay, next section is about some theories of why language models are fun or what we're enjoying about them. One theory I have is that language models confirm, or at least feed, our suspicion that the real world is fake. This is a list of bands from Real Coachella 2023. And I don't know if any of you have ever heard of Danny Lux or Overmono or the Sleaford Mods or Pausa, but I never have. Or if in the course of daily life we are confronted by a poster that tells us Danny DeVito is Dorgal, are we just supposed to accept this? Or if we get an email that tells us you can earn $5 when you pay for Chegg with Venmo, it's asking you to be pretty receptive and adaptive. So if this is what the real world is like and it doesn't look that different from what language models make, then maybe we have a friend in language models whispering, yes, you're right to be confused. Or maybe we have a teacher in language models that can teach us acceptance, because a language model would say, yes, Danny DeVito is Dorgal. Yes, I will earn $5 when I pay for Chegg on Venmo. And then it will ask us, did you hear Fanch is headlining Coachella? Or maybe language models are conspiracy theories, because we know that they're models. We know that they are simplifying and really not thinking in the same way that we are thinking. And so if a small language model is able to produce what we're seeing in the world, maybe there's someone high up there who's cheating, and instead of thinking, they're just saying words that they heard, or making up words that look real. A language model seen this way is an accusation that someone or something is acting without thinking. And the choice of tokenization informs the specific type of accusation that we're making. So if we say, you sound like a character level neural network, we're saying one thing. And if we say, you sound like a word level neural network, we're saying another thing. We might be saying, you've just found these words that seem to get you far in the world. And we're not gonna take it anymore. Yet another framework for thinking about language models comes from Emily Short, who gave a great talk on procedural generation and what is interesting about procedurally generated text. And she has a framework of 5 different ideas that come from working with machines and co-authoring things with machines. We have SALT, that's about fixed structures that come from the way that the generator uses templates. Venom is jarring turns of phrase, like the dead heat of time, maybe, from the Statue of Liberty one. Beeswax is many authors combining to make one work. Mushroom is the tendency to repeat oneself that comes from using a generative model. And egg is about this human feedback cycle. I want to focus just on beeswax for a little bit. And notice that there are different kinds of beeswax that you can buy in the real world. One, which we might think of as artisanal honey, is more like small language models. And the other that's like the dreaded bear from the supermarket that contains more processed honey is like large language models. And there's something, even if these are giving us some version of the same thing, there's something that seems to matter, to me at least, about knowing that this is connected to a real world thing, that maybe this is connected to a specific data set, and knowing where the words that I'm seeing are coming from. And not just being able to explain it to myself, but being able to explain it with some effort to an audience. So if I'm looking for a list of some good things to continue extolling small language models, they are close to their data and provide a kind of view of the data. They are easy to design and explain. They are fast to implement and to combine. They make really bad mistakes sometimes, which I think is a plus, at least certainly in the context of comedy writing, but maybe it's nice to be able to reason about what kind of mistakes a model makes might inform how you want to change it, and so it gives a transparency to them. And I think that they're also relatable, because we can see them struggling to grapple with the world, just as we struggle to grapple with the world. And so, in contrast to maybe a larger model that will be built to always seem somewhat authoritative and friendly, we can maybe feel that, yeah, just as I feel like I'm putting word after word and not really knowing where it's going, a language model freely admits that, or maybe involuntarily admits it, but isn't good enough to trick me. Okay, this is a brief aside to give you another sort of visualization of what is happening when we're choosing these predictive text words in the tree. We can think of it as, again, a branching tree, but we can think of it as getting ever smaller. So I have a lot going on in my life. This was the phrase from that 2019 Android predictive text that you saw at the start of the show. And I actually think I explored all of these branches and found what these words actually were. So this is accurate. But we can imagine collapsing these into a thin point and saying, once you have made 8 choices, there are now 6,000 some possible messages, 3 to the 8th possible messages that you could have written. And each of those messages is going to live somewhere along that line. And we could even label that line with the numbers that floats between 0 and 1. And there's an analogy here to arithmetic encoding, which says sequences of tokens are afloat between 0 and 1, specific enough to specify one path down this branching tree. And so if we encoded a sequence as 0.34578, that might correspond to, I have a lot going on in my life. Or if we chose another sequence, 0.59259, then that might correspond to a different message. I am so glad you are doing better. There's also an analogy to what happens if you're trying to improve your language model and make it maybe a little more automatic and a little more of a guided representation of the world. This is like in adaptive arithmetic coding, where we can change the size of these ranges in order to make more likely sequences more likely. So we can, if I turned out to be the most likely one to start out, we could widen it, and we could widen half within that I, and so on and so on. And this might mean that we need less precision in order to specify the output. I have a lot going on in my life, which might be a really likely output. And so this is something I sometimes think about when I think, what are better and better models trying to do when they change the way that they encode text? One way of thinking about it is at each step, instead of just 3 words, we have all the characters or all of the subword tokens that might be available to that model. We have enough choices at every step that we could, in principle, unlike this, produce all sequences. And then our challenge is sizing those windows so that more likely sequences are more likely. And of course, it gets to the point where the states are much more complicated than just one word. So at some point, maybe it becomes a less useful analogy, but I like it. Okay, this one's a bit scattershot, but we're going to go through it real quick. Inspired by Ted Chiang, who posted or wrote, everything's a post, I guess, wrote a New Yorker article proposing a lossy JPEG as an analogy for understanding large language models. That large language models are like a compressed representation of the internet. I want to propose a few other metaphors that we might think about in light of this talk for text generation. Some of them newer than others. We can think of navigating a language model as like moving through a maze of possibilities. We could think of them as basically fridge magnets that constrain you to the vocabulary of a source text for fun. We could think of it as a ransom note that is rearranging a source text for not fun. We could think of it as a kind of scrapbook of places we saw along the way during our travels on the internet or through text. Or we could think of it as a kaleidoscope that is a view of reality, but is shifting things around a little bit and fragmenting it. And in the last section of this talk, I want to explore this kaleidoscope metaphor through karaoke, where it starts with thinking about, well, what is the creative process? How does the creative process sometimes work? One story I've heard specific to the Beatles is that before Yesterday Was Yesterday, it had these lyrics: scrambled eggs, oh my baby, how I love your legs. And then that was a placeholder while writing Yesterday that was changed to the song we all know and love, Yesterday, Love Was Such an Easy Game to Play. And the question is whether we can try to automate this with a minimal model, with a simplification of what's happening here. And to do that, I'm going to show you one of my favorite resources, which is the Carnegie Mellon University Pronouncing Dictionary. This is about a 4 megabyte file of pronunciations of English words. Usually they're North American English pronunciations, and it's written in this nice format called ARPABET, which is both human and machine readable. I'll show you what that means. So we have entries in the CMU Pronouncing Dictionary. It's surprisingly comprehensive, at least in my book. It has words that you might not expect to be in there, and we have each word represented as the literal text you would see, the phones, the phonemes that make up that word, and they're separated by 2 spaces. It has fonts. It has, this is an example of opening the CMU dictionary in Python. We can get the words in the phones and then ask it what the pronunciation of Fonzie is. It gets it. It doesn't have everything. We can ask it the pronunciation of A. It gives us an error. But it's pretty good, and it's going to get us pronunciations of quite a lot of words. And so this is the backbone of a world-conquering technology I am building called the Weird Algorithm, which works like this. For every line in a song, we are going to find lines with similar syllable counts, rank them by phonetic similarity, and choose one. and then sing the new words. And I'm going to show you what this is like with the example of yesterday. So let's open up the command line version of this. Let's choose yesterday. Where is it? It's under the Beatles. Let's choose a source text that we're going to use to replace it. And I'm going to choose one of my favorite ones, which is Craigslist ads for vehicles. And then we're going to play it. Hopefully, this doesn't get us blocked from YouTube for copyright infringement. Good luck. Close Sunday. Come check it out at Fresh Rides today. Stop and go rear hatch with hidden tray. This is a really nice Hyundai. Line assist might deliver elsewhere for a fee. I'll get back to you ASAP. Brake or transmission, fluid loss, just run VIN below, chassis no, or every day. Good work, truck runs strong, driven mostly on highway. Anyway, what you will need to drive out today, ready to upgrade your ride today, was running great until Sunday. What you need to know, engine no in stock today. This will not last long, nothing wrong. New main relay, all highway. Why is it a good day, do you say? This truck is ready for work or play, so most of the miles are highway. Okay. Thank you, thank you. All right. So we're a little short on time. I'm going to run through some possible lessons that we could take from all this. One, the more positive lesson is that poetry is all around you. You might not realize it, but anything you see or hear could be poetry. A more sinister lesson is, especially when online, you are always on the record, and anything you say can and will be used against you in karaoke. A third lesson is that you could be part of future poetry. So anything you are working on right now and committing to the public could be recycled later with or without your knowledge. And I don't know, all of these make me feel conflicted, but broadly I'm excited to be part of a long contingent line of connections. And these connections include, I want to acknowledge, an inspiration for this karaoke generator is this Teenage Mutant Ninja Turtles Wikipedia titles bot, which scours Wikipedia titles and finds ones that are singable to the Teenage Mutant Ninja Turtles theme and posts them to Twitter, or whatever the site's called now. It's a joy. And even this is not the end of the chain of acknowledgments. We could trace a linked list of citations that starts with karaoke and goes back to the Teenage Mutant Ninja Turtles Wikipedia titles bot, which goes back to an XKCD strip about the same concept, which itself is indebted to the Teenage Mutant Ninja Turtles themselves, which themselves are based on turtles, and it can go on and on forever. And we should also note that this isn't just a list. This is more of a graph. There is the Teenage Mutant Ninja Turtles logo generator that informed the bot, or that was crucial for the bot, and based on the same comic strip. And karaoke, of course, this karaoke demo is combining songs and texts and is based on the tradition of karaoke. And Teenage Mutant Ninja Turtle Wikipedia bot is based on Wikipedia. And you can check the alt text for this comic, and it mentions linked list, which is a reference to this slide. And so it's all sort of connected, goes around and around. I want to close with one last karaoke a cappella that we're all going to do together. And this one is based on a tune that I hear is popular in St. Louis, or at least known. It's Judy Garland's Meet Me in St. Louis. And I'm just going to show you how it works in this newfangled interface I'm working on for karaoke, to annotate Meet Me in St. Louis. We're going to get these CMU pronunciations, and we can input, well, this one that it doesn't know is Tootsie Wootsie. So we'll give it 2 stresses, and we'll give it these vowels, and that'll allow us to print the representation of it. But I've already done this. I've worked ahead. And using strange loop talk titles, we are going to sing together Meet Me in St. Louis, Louis, with Meet Me in St. Louis, Louis, that is, with strange loop talk titles as the source text. So the song goes like this. Meet me in St. Louis, Louis, meet me at the fair. Don't tell me the lights are shining any place but there. We will dance the hoochie coochie. I will be your Tootsie Wootsie if you will meet me in St. Louis, Louis, meet me at the fair. Okay, so that's the tune. Now we're going to do it with new lyrics. Is this big enough to read? Oh, okay. That might be a problem. Let's just make it bigger then. How's this? Better? All right. That's worse. All right. Here we go. 1, 2, 3, 4. If only I owned my data, the semantic web. Becoming a tech activist, getting physical. It will never work in theory. It will never work in theory. Make your mobile apps accessible to all. Ideology. Okay, that's it. Thank you.